What's up, y'all? This is Hussein Nasser from iGeometry Podcast, and welcome to today's podcast, everybody. Today's MLK, it's a holiday, it's a Monday, and also it's another podcast day. I don't have a day for a podcast, but yeah, I felt like recording another podcast for you guys today. I'm actually getting some dinner for us today, so let's talk about stateless architecture, right? So it's actually a very interesting topic. The way we've been writing apps or applications for past, I don't know how many years, has always been you make a request, right? The client, let's say a client server architecture. A client makes a request to do something, and the server does that, and then somehow stores the state for that particular session, right? And then the other request comes in from the same user, and the server knows, hey, but okay, yeah, I know for sure, I know this user, he just made this request, right? This kind of architecture is called stateful. That means the server somehow remembers, specifically in memory, right? He stores in memory, says, okay, I did something, I stored a state for that particular session or user, and I have information about that state. And that sounds cool, right? Because, hey, you have to store something in memory for caching purposes. But what you give up when you do that is scalability. And we talked about scalability in a lot of other contexts. But what happens here is, and let's take an example, right? So we talk about the stateful in this case. So let's take another example where stateful might be harmful. Okay. So let's think about Instagram, for example, right? Let's say I just installed the app. I installed Instagram. I just opened Instagram. Instagram detects that, okay, looks like you need to be authenticated, mate. So what Instagram does is that he connects a server. Let's assume we have one server here. And you talk to a server, it says, okay, server, hey, West Coast, authenticate me. This is my username, this is my password. Authenticate me, please. So he does his work. Finds, yeah, sure, yeah. Hussein has an Instagram and HNASR, and yeah, looks like he's legit. So I'm gonna store that authentication token in that server just to be sure, right? So I stored in memory. So Hussein has been authenticated. So next time, if Hussein makes a request, I know him, right? That's happening on server A. Cool. So my request is turned from server. I'm authenticated. Now I'm gonna make another request to actually open my feed, right? What will happen here is we're gonna query the same server, and I'm gonna give that user a token, right? Says, hey, this is my token. So the server takes that token and says, oh yeah, it looks like that's legit. I found it in my cache. I found it in my memory. So what I'm gonna do is actually, okay, I'm gonna authenticate you. I'm gonna make that query successful, and I'm gonna query the database and retrieve the pictures. So what looks bad about this? So far, everything looks okay. I'm making a request. It's a normal request. I'm saving the information, the authentication in memory. That looks legit too. So we're gonna discuss in the next segment what is actually bad about this. Stay tuned. All right, so I've been authenticated on the server, right? And the server A, let's say, now remembers that I'm authenticated somehow, right? Stored in memory. So the next call to the function that calls get pictures, which is get feed in my Instagram, will basically first check, hey, does this user have a token? So the server will say, yeah, this guy has a token, so okay, go ahead and actually make that call, retrieve the pictures and retrieve them, right? And return them to the user. But how this breaks apart is, what if you decided to have two machines as your server, right? So what will happen here, you'll make a request, we'll go to the first server. That's the let's rewind that authentication scenario, right? So I open Instagram, I'm about to authenticate for the first time. Username, password, hits the first, right? I send the request. That request goes to the first server and it authenticates me. Says, okay, you're chill. Go ahead and actually store that and persist in machine A. So I had machine A at the first request, right? So now machine A knows that user Hussein is okay, right? So I go ahead and make another request, and now since we're doing load balancing, so we could hit any machine, and I have machine B. And since we're making an assumption that we have been authenticated, right? So the function get picture, or the page, or the service get picture always says, is this user authenticated? And guess what? Machine B does not know anything about the authentication of that user, which is me, right? So what will happen is that request will fail. So as a user experience, you just authenticated, but you failed to retrieve the feed for some reason, which is really odd, right? And that's what happened when you write a stateful application, especially when you try to scale horizontally, right? So at the server level, you want to add more machines, but since your application is stateful, you will have to re-authenticate yourself every time. Not a really good experience, right? So a stateless application will allow you to scale beautifully because it doesn't actually store a state in memory, if you know what I mean, right? It doesn't actually store that in memory. It uses other methods of persisting states, maybe usually through a database or a central database, right? So that's one example. So let's rewrite our application here on Instagram using this approach, which is the stateless. So what I would do is I'll make the request, right, to authenticate. That goes to any server, and what will happen is I will try to authenticate that user, and once that user is authenticated, I'm gonna return a token to the user. It says, hey, user, this is your token. Every single request you send, you better send this token with it, right? You don't rely on the server to remember that you have been authenticated before. You just don't, right? So what you do, in this case, you return the token. The user now, as an Instagram client in this case, will be responsible to send this token with every request. So the next request will be, so he got authenticated, now give me my feed. And by the way, this is my token, this is me, right? So you are kind of like re-authenticating yourself every time, but it's much more efficiently because you're going to do something in the back end to solve that. But now you're just writing a scalable application because of that. Horizontal scaling. All right, guys, so that was a quick stateful versus stateless architecture. What do you think, guys? What should we discuss next?